The following presentation is a deep dive into eventing architectures when it comes to building large-scale, or what we call web-scale, systems. This is based off both a combination of architectural theory and my own practical experiences, having implemented a number of these systems at very large scales at this point. What is eventing? A lot of people will start describing eventing in terms of publish and subscribe, or pub/sub. What's important to note that eventing is not pub/sub. There are some major differences here, so I'll sometimes refer to eventing as pub/sub plus. Consider that in a pub/sub type architecture, you are putting a message on some type of queue or a topic, and things are listening to that message and pulling it off. It's fundamentally an asynchronous architecture, but with eventing, there are some key differences. Specifically, when looking at technologies like Kafka, when you publish an event, that event is also persistent for some period of time, anywhere from hours to potentially years. And so there's an inherent persistence with an eventing architecture. Additionally, when you publish a message using a messaging technology like IBM MQ or RabbitMQ, once that message is consumed, it's gone forever. In eventing, it works more like a broadcast, so you publish an event and then anyone listening for that event will get a copy of that event. Another key aspect of eventing is architecturally, it is prioritizing availability over consistency. This is referring to terminology used in CAP theorem, which we'll get into much more details later. As a result of that prioritized availability, the system is eventually consistent, meaning that transaction boundaries really don't exist at a large scale from an end-to-end perspective. When we say eventually consistent, that means that you can do something in the system, but have to keep asking a question, sometimes over and over again, until you get a consistent answer. This is because of the fundamentally asynchronous nature of something. A good example of an asynchronous, eventually consistent system is an ATM. Consider that that ATM may not be directly connected to a bank, or the connection may be spotty. And so when you're at an ATM, it has things like limits. You can't withdraw more than $200. And in terms of eventual consistency, if you overdraw your account, eventually that bank's going to come back to you for their money. CQRS stands for Command Query Response Segregation, and this is an architectural methodology for dividing up the functioning of a system in terms of how you put data in and get data out by separating commands doing something versus querying getting something, and then separating that, really creating a system in which you've broken the read and write path. So in comparison to CRUD, create, read, update, delete, we'll get into a very detailed example where we compare CQRS to CRUD. Lastly, domain-driven design is something I've come to use when dealing with eventing in CQRS. This is because CQRS is inherently very complex, and one such result is you end up with many more applications and components, and trying to organize these types of components and services in a meaningful way can get really complicated. I find that organizing these services and functionality into domains makes it a lot easier to architecturally conceptualize how a system works, especially when a system can get so large that at a low level it becomes impossible to actually maintain how that all works inside of one's head.